All right. Well, happy Wednesday. Couple things today. I think the lab went okay. Not great. It was okay. What do you think? We did all right. It is different for sure. Definitely a little bit different trying to use our classes. Um, we do have to talk about the project. Sorry, I meant to do that on Monday, but got a little bit sidetracked. We had a lot of stuff to talk about. So, talk about the project today, as well as finish up classes. We don't need to go super deep with classes because this is a big topic for next semester. If you do continue on in 2001, we'll do a whole deep dive on that. But so squeaky. Want to get at least the idea in our heads and start practicing with how we can use them. We won't do tons of super interesting things with classes yet, but we'll get there. Um, Next week, exceptions and modules is a little bit shorter, not as much going on there, so it'll be good. So we got some time for the project, and then we'll pick up files the week after that. This is a huge topic. Files are fantastic. We're going to start easy with files, not do anything super crazy or advanced. Local files are great, but most of the time when we work with data that is going to stay around between program runs, it'll be with the database or some sort of web service call or other sorts of things here. So we'll play with files, but it's not anything we'll like always necessarily keep doing. And we'll talk about the final project. And then we've got Thanksgiving break for a week. And then we've got a couple topics. Inheritance we're going to touch on. Again, it's here. We're going to come back to it next semester, go a little bit deeper. We'll talk about recursion. Again, that's a topic we pick up again deeper next semester. Look at some of the cool Python for data science libraries we can do. The week after that is just set aside for final project work time. You're welcome to work in pairs on the final project. You don't have to. It's not a requirement that we do group work. But we'll get there eventually in some of our classes where you are required to do group work. Uh, so think about it. You don't have to if you want, but it's a good time to meet up with your group there if you want to. Um, and then on the 13th, we have our presentations for our final exam slot. So ideally, if you can get it done by the 6th, right between the 15th and the 6th, so 3 weeks or so. I know there's break in between, but I don't know. Maybe I've got some time during Thanksgiving break to work on. I feel a little bit bad, but most people don't take the whole week off. If you can work ahead then you can get it knocked out and done so you don't have to worry about it during finals week. Sort of the idea there. I can go around and help. So should be a lot of fun, but we are just on November 1st and already looking at the end of class, believe it or not. So not too much more going on as we go. Okay. All right. So let me fire up PyCharm here. And let's see. So we did some of classes. Constructors. We'll talk about interfaces later. That's not too big of a deal. I got to turn some of these on here. Sorry. So lots of practice with these in Xylabs. What do you folks think of Xylab so far? I know everyone says tedious, but is it worth it? Do you feel like it's giving you meaningful practice, or is it just busy work? Like, if it's just busy work, I don't want it. But if it's good practice, then it's definitely worth it.
Most of it is pretty basic. Very few projects we have to work on.
So it's not challenging necessarily, but it's practice, right?
Yeah.
Okay.
So,
I think that's probably a good measure of what like they shouldn't be hard to do. They should just take some time and get you into some of the syntax and practice these topics and things. So I think that ought to work well. Look, we can calculate a triangle's area with a base and a height. Right, so triangles have attributes for base and height. They're not doing any of the private stuff. Don't worry about it. That's okay. You can set the base. You can set the height. Sure, go for it. And then area is 1/2 base height. Go for it. So we need to create triangles using set base and set height. Set base and set height. Figure out which one is smaller, right? Because get area will return a value. We can figure out which one is the smaller triangle. So just some practice using these things here, ideally. So for what it's worth, you do pay more because they turned on Xylabs. The cheaper option is just the book without Xylabs. But again, I think the practice is probably worth it. I'm still maybe a little bit on the fence there, but we'll see what you say. Okay, so we got classes. So most of what we did was looking at how do I know, or how do we know if it worked? Right? We wrote a class to do something. Let's go back. The Connect 4 is a little bit harder here. Let's go back and open up our recent. There we go. Chapter 9. So we did the chair class or the car class here, right? How do we know if this worked? Because the idea here is I know what the code is supposed to do, right? I know it's supposed to let me charge, but not charge more than the max. I know it's supposed to let me drive, but not drive further than I have the charge to do. These sorts of things. So what we did is we wrote some code and we kind of eyeballed it, right? We created cars, we charged them, we drove them, and we had to look at the output. Now, have you ever written an English paper and tried to proofread it yourself? We're not very good at it, right? Because we know what it's supposed to say, so it's hard to notice when we don't write what we meant to say, right? Does that make sense? So, same idea with code. I know what it's supposed to do, but it's harder for me to check the output and see did it actually spit out what I expected to do because I know what it's supposed to spit out. Right? And it's easy to skip over those sorts of details. So turns out there's a better way to test our code to make sure it's working properly. Right? You know who's really good at not missing details? Or what's really good at not missing details? The computer. Computer's pretty good at that sort of thing. So what I'm going to do, I'm going to write unit tests. So unit just means it's testing one small unit, one small chunk of code here at a time, is what we mean by unit. So I can make the computer test my electric car class to see if it did what it was supposed to do. So I'm going to come up with my car class, I'm going to right click on it and say go to test. And PyCharm says, I don't see any tests. Do you want to make new tests? And we say, yes, please, PyCharm, make some tests. And now I get a bunch of stuff. This is a little bit crazy. That's okay. So it says, hey, I'm going to make a new file called test main. I'm going to test the test electric car class, right? And what do I want to test? Now, a good rule of thumb is any code that's worth writing is worth testing, right? Do you care if your code works and does what it's supposed to do? Everyone should be saying yes, right? We care that the code works and does what it's supposed to do. If you don't care if it works, why'd you write it in the first place, right? If it doesn't matter if it does what it's supposed to do, then don't write it because it doesn't matter, right? Otherwise, you just have garbage. So if we want to make sure it does what it's supposed to do, we want to test it. Now, the only thing we've done so far to test it is run it and give it input and check the output. Say, okay, if I give it 10 for a height and 5 for a base, do I get 25 back for my area, 1/2 base height, right? I can do that sort of in my head or on paper and look at the output and see, does it do what it's supposed to do? But that's error prone, right, at best. So we're going to make the computer do it for us. So I'm going to test charge. I'm going to test drive. All of the gets, I don't really care about right now because I don't want to test them individually. I'll show you there's a way to test them all together here in a minute. And then I'm going to test set color as well because this is one is really boring, but I do care that code I wrote works. So I'm going to test it. So anything that's a get, I'm going to basically ignore for now. But the other functions I want to test, I'm going to say, okay. And now I get a new class here. So now I have more than one file. Starts to get a little fun here. So I have the main file and I have my test main file. I'm testing main. And it adds this import for me. So built into the Python library is this thing called unit test. So Python knows how to unit test code. It's fantastic. And it's got all sorts of good notes about it here. So what it does is it checks to see if our code runs and if it does what it's supposed to do. So right now we get 3 methods. We have test charge, test drive, test set color. There's conventions when it comes to testing. So anything that we're testing should start with test. So these are functions of the class. Don't worry too much about it. It's okay. But if you want to add more tests, we need to start with the word test. So I do want to do one more test. That wasn't an option for me. I'm going to test the init method. So this seems a little tedious here, but the reason is I want to make sure that if I give it a make, model, color, max kilowatt hours, and that kilometers per kilowatt hour, I can get those back out. And then the things that I'm setting to 0, like my odometer and my current kilowatt hours, I'm going to check those too. So I'm going to say, when I make a new instance of electric car, does it have all the attributes that I expect? Right? And I'm going to go add a new function here. So this will be define test init. Right? So there's 3 things we do. So you're going to arrange, we're going to act, and assert. Again, this is conventions in conventions. There's multiple ways to write unit tests. This happens to be probably the most popular one in the industry. So what we're going to do is we're going to set up, we're going to arrange all of the things we need to test. Then we're going to act. We're going to call the code that we're testing. Right? So this calls the code that we are testing. This is to set up all the variables we need to test. And then assert is, did we get what we expected? That's all it is. So to set all this up here, I need a bunch of variables, right? So all of the things I'm going to check for, I'm going to create in a range. So with a car, I've got make, model, color, odometer, max kilowatt hours. I've got all of these things. Let me just copy this list, actually. This is probably fast. I'll take this one. I'm going to take the self off of all of these because I just need local variables in this function here. So I'm going to variables for all of these values here, and I'm just going to set them to something. So let's do my Chevy Bolt, and mine is gray. I expect this to be 0. The max, I don't know, what did we say was going to be like 250 or something? Current should be 0. At kilometers per kilowatt hour, I think it was like 5, something like that. So all of these are values that I'm going to expect to get back out. So it's a little tedious, but I'm going to add the word expected because this will help tell me this is the value I expect. Again, just conventions. So I have expected make, expected model, expected color. These are all the values I expect to get when I make an instance of electric vehicle or electric car, right? So that's all of the variables I need that I expect to get back out. So I've set everything up. It's ready for me to go. Now I'm actually going to act. I'm going to call the code I'm testing. Well, I'm testing the init method here. So I'm going to make a car here equals an electric. Oops, I got to go import it here. So we haven't got to modules yet. So this is a little bit weird, but we're going to say import main. So main is the name of the file over here. So we just give it the name of the file over here. So, and then we want it's main dot electric car. It's a little weird. Don't worry too much about it. We're saying, hey, in the main file, find the electric car class, right? Then I give it all the things. So I have to give it make. So I'm going to give it my expected make. I'm going to give it my expected model. I'm going to give it my expected color. I'm going to give it my max kilowatt hours in battery, my expected max kilowatt hours in battery, and my kilometers per kilowatt hour. Expected kilometers per kilowatt hour. That's a bunch of variables, right? But I'm going to give it all of the things the init method wants, right? You have to give it make, you have to give it model, color, max, and kilometers per kilowatt hour. So now I've created an instance. I've called the init method here from my vehicle class. Now we need to go get what the values actually are. So what I mean by actually are, what does this car think its attributes are? So now I'm going to make a bunch of variables for the actual here. And again, copy paste, it's a little tedious here, but we'll get there. So I want an actual make, an actual model. There we go. Actual, 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 actual. And now I'm going to go ask the car what its attributes are. I'm going to use the get methods to go get the actual value though. So car.getMake will say, hey, car, give me the value that you have for make. Right? Car.getModel. Car.getColor. Car.getOdometer. Car.getMax. Car.getCurrent. And car.getKilometer per kilowatt hour. Right? Go use the public functions we wrote that give us access to those attributes. Right? So now I've got, this is what I expect them to be. This is what the car actually thinks they are. And now assert says, did we get what we expect? I'm going to say self.assert equals, and I give it the expected and then the actual. So expected make and the actual make. So a bunch of copy paste here, right? But we're going to change the variables around. The init one's the longest one. We'll get there on the faster ones here. So I'll do expected model and expected color. Again, I'm just double clicking to highlight the whole word here. And I can copy paste. There's probably other ways to do it here, but this is what I'm going to go with. Expected. Now we'll do the actuals. Actual model, actual model. So actual color, actual color, actual odometer, actual odometer. Actual max, actual max, actual current, actual current, actual kilometers, right? So 3 sections. So I've arranged all the things I need. These are all the values I expect to get out. This is the code I'm testing. I'm testing the init method, and then so this is why I don't have separate methods for get. You could write a test that's just get make, where you make a car and then you get make. But you're doing it anyway when we test the init method. So that's why I skip all the get methods. So all of the get methods are tested essentially when we test the init method, because that's how we get out our attributes here. And then assert, we're asking the computer to check, hey, do these things match here? right? So let me put in here, instead of expected make, let me just put Chevy with a lowercase c, right? So if I expect Chevy with a lowercase c, but I give it Chevy with an uppercase c, do you think it's going to match? No, it won't match. So now I can right click and I can say run tests, or I can come up here and hit the little run button here. Now when I run the tests, I get this really cool test explorer, which is really nice. So test init here, if I click on it, says, hey, it failed. Um, oops. Did I mean assert equal? Okay, yeah, I must have meant assert equal. Sure. That's weird it gave me equals, but sure, why not? Okay, let me try that again. We're gonna run it again. Run tests. Okay, test init. It's saying, hey, Chevy doesn't equal Chevy. Right? You expected Chevy with a lowercase c, you actually got Chevy with a capital C. Right? The computer's going to check for that for me because it checks, make sure strings match case by case by case. So let me go back and put my expected make back in here. And if I run my test, right click and run the test, now it passes. Um, by default, it filters out tests that pass. So you can go and click the little checkbox here. Then you can see test and it passes. Most of the time, you only care about tests that fail, right? Because it didn't work what we expected here. So looking good so far. So test and it passed, right? And if we want to change any of these things here, like put in 23 and then run our test, we'll see same idea here that 250 does not equal 23. We expected 23. We actually got 250, telling us at line 30, right? So you can go find the line, find out where it's failing. Now, the other cool thing we can do is we can debug our tests, right? So I can right click in here and say, hey, I want to debug the Python unit test. So we'll pause here for me. Let's see. Oh, it's already a breakpoint there. So we'll continue. Nope, not stop every run. Sorry. Continue here. There we go. So now it's about to do this line of code, right? We paused here. So I can see I have this car, and I can open it up. I can see all of its protected attributes. I can see all the values in the car class, this instance of the car class. I can see all my variables here for my test. And if I want, I can step into my code for, oh, sorry, there was no code here. I should have stopped one of the gets here. That's be a more interesting place to pause here. Sorry. Let's try that again. Debug the test. Okay, so now if I step into my code, I see self is this instance of the car. Remember, self is this instance of the class here. And I can see all the attributes are set. And I can see I'm about to return my odometer in kilowatt hours, or odometer in kilometers. It's 0, right? So you don't have to write code to actually make instances and print stuff out on the screen, right? That's the beauty of it, because we don't care what shows up on the screen right now. One of those ideas with our class, like we do with that Connect 4 game, is how do I separate the input and the output from the class? The idea with the class is it's just the logic. It's just encapsulated all those details that we need together into what is Connect 4. The class itself does not care how it's used. It could be used in a web application. It could be used in a console application. It could be used in a graphical user interface application. It could be used on your numworks calculator when you're bored in math class and want to play Connect 4 instead of do calculus, right? The class doesn't care how you're doing input and output. The class wants to contain all the logic around what is an electric vehicle, right? How do we separate all that out? And you interact with it with its public functions, that idea of abstraction. All you need to know is what are the public functions. You don't need to know the details behind the scenes. Does it do what is advertised? What are those public functions? So when I write unit tests, it lets me not have to put code down here and actually look at the output and see, okay, I expect this to work. What do I expect the value to be after the fact? Right? So we tested the init method, right? So now charge and drive are going to be a lot faster. Well, we'll do set color. This will be a lot faster to test. So again, we're going to arrange, and we're going to act, and we're going to assert. So arrange is all of the stuff I expect. So I'm going to have an expected color. Let's say is blue. Maybe I want to paint my car blue. Okay. Now I also need a car to work with. So I'm going to make a car equals up main dot. Yeah.
So,
Self. So self is for class level attributes that exist everywhere in the class. I don't care what expected color is anywhere other than my test for color here. I don't need one color that's shared among all of these methods here, all these functions here. I only care about it inside this function for test color. Yep. So I need to make an electric vehicle, or electric car here, that I'm going to use when I set color. So I don't actually care what the make is. I don't care what the model is. I'm going to set the color to black to start, right? Something that's not blue, right? And then I don't care what the other values are. I'm just going to give it zeros because they don't matter, right? I'm not testing those pieces here. So I make a car that I can go and test with later. So in my act code here, I say car.setColor. And I'm going to give it my expected color. And I'll have an actual color is car.getColor. So after I set the color, can I go get it back out? So I'm going to set it. I'm going to give it blue. Do I get blue back? Right? Then we can say self.assert equal my expected color, my actual color. So I give this one a run, and it passes. Right? Blue matches blue. If I forget to set it to blue, right? If I don't call set color here, it starts as black. Black does not equal blue, right? I never changed it. So you can see it's checking did set color change. Now, a lot of times testing sets are kind of tedious. And if you have a lot of set methods, it's a lot of typing, but it's not the end of the world. I mean, it goes pretty quick, right? It's test them here. If you want to group them all together, you can have like one test. You don't necessarily need to test just one set color. Like if you've got 5 different set methods, test them all at once. Go for it, right? Generally, you want to test one small bit at a time here, but most of the sets are pretty boring. So there's not a whole lot of stuff going on. Now, charge and drive are a little bit more interesting. So charge in my class here has a little bit of logic happening here, right? So I'm going to add the kilowatt hours to charge. And then if I went over the max, stop at the max. So in order to test if this does what it's supposed to do, I want all of these lines of code to run. So I need to give it something more than my max to make sure it stops at the max. Because if I only test, hey, if my capacity is 250, can I add 50? This line of code never ran. So there's this idea that you call code coverage or test coverage. How many lines of code of your class are actually running when you run your tests? And the goal is to get 100% code coverage. You want every line of code to run when you're testing it. Now, that's a great goal. In practice, it can be hard to get there because, as you can imagine, classes that have this business logic can get more and more and more complex depending on what we're modeling, right? This one's kind of basic, but in the real world, right, what does charge work and how does it happen? And, what kind of amperage are you getting on your charge line in and real details, physics get in the way. The real world is harsh. So sometimes it's difficult to get to 100% code coverage. I still stand by the statement that any code worth writing is worth testing, right? But in the real world, when you pay a developer to write code, you want it to work, right? But if they're telling you, hey, I have to go write a bunch more code to test my code, you're like, really? And so the people who sign our paychecks sometimes say, you don't need to get 100% code coverage because that one tiny case you're saying, well, what if I only get 1 amperage in? What's happening to my charge when I'm trying to charge with 1 amp? Like, don't worry about that part. You're like, that's kind of an important one here. So sometimes it's out of our hands. What do we say? It's above our pay grade for the people who make those decisions. So like, don't get yourself fired because you're like, I need 100% code coverage. You can say it's a good idea and you can say you want to make sure it works, those sorts of things, but it's a goal. And then the other piece of it is even if we get 100% code coverage, it's still possible to screw things up. It's still possible that I typoed it in my code and I typoed it in my test. Or I just misunderstood what I was supposed to do and I'm testing that it does what I've misunderstood. Right? I just have flawed logic. The code does what I've asked it to do, and I'm testing does it do what I asked it to do, but I didn't understand the problem right. I didn't solve the right problem. That can happen. So just because you have code coverage doesn't mean your program actually is bug free. It's not a guarantee. But you're more likely to catch your bugs, more likely to catch your errors if you're doing your unit test. So it's handy to have the unit tests, but it's not a guarantee that your code's perfect. All right. So when I'm going to test charge, then, right, I'm going to have my arrange, I have my act, and I have my assert. So I'm going to have an expected current kilowatt hours. This is my expected current kilowatt hours in battery. So I expect to be able to charge up to, say, 250. Again, pick a number, doesn't really matter too much here. I'm going to make a car equals main.electric car. I don't care about the make. I don't care about the model. I don't care about the color. I do care about the max kilowatt hours. So the max kilowatt hours should actually probably be my expected here. And the kilometers per kilowatt hours I don't care about. Okay. And then what am I testing? The code I'm testing is charge. I'm going to call car.charge. Now I'm going to give it the expected times 2. I'm going to double that because I just want to give it something more than the expected, right? Because this code only runs if it's greater than the max. So I should be able to charge to 250, and this line of code will never run because it's not greater than 250, right? So something more than that, or even like plus one, how about just plus one? We'll do that. We'll charge that plus one. And then I'll get the actual here. So I'll have an actual. And again, a lot of this is copy paste. You can go find, if you've already done it once, just go copy paste it from somewhere else. And then we can assert, does the actual match those? Oh, I should put this back. My expected max. There we go. Right? Does my expected match the actual? And this is why, like, if you keep the same naming convention for your variables, your expected and your actual, it's easy to copy paste between the different tests. And again, this is why you can have buggy tests, because I copy pasting it all the time and forget to change things. So it might be bad. But let's give it a try. So let's run this here, and it passes. So we expected to get 250 when I asked it to charge 251. It stopped at 250, right? All of this code ran, code coverage. Now, the paid version of PyCharm will actually measure this stuff for you. It's one of the cool bells and whistles. We don't need to pay for it to use that bell and whistle. We're just going to eyeball it here and say, hey, I'm going to look at my function and does all of it run here. So for drive, again, we have two different things that can happen with drive. So I'm actually going to write two different tests for drive because one, these 3 lines of code will run if this is true, and another test where if it's false, this line of code runs. Right? So I'm going to make two tests. So I'm going to have a test for drive. I'm going to call this one successful. I'm going to make another one here when it's unsuccessful. Okay, because I want all of the code to run. I want to get 100% code coverage. Okay, so for drive to be, let's do unsuccessful first, because that's the fast one here. So I'm going to have I'm going to arrange, I'm going to act, I'm going to assert. So for drive to be unsuccessful, just making a car, pretty quick and easy here. So let's just take this line here, right? Don't really care about any of those here. I can give it 0, right? I'll make a car. Now I'm going to have an expected drive result. Expected drive result. I expect it to be false, right? Because in my class here, if you can't drive that far, it returns false. So this function is giving me something back here, right? And then I'll have an expected odometer. Let me just go copy paste that because I can never type that. Expected odometer in kilometers is 0. Right? That shouldn't change, and my expected charge should still be 0. Current kilowatt hours in battery should still be 0, right? Now, this is a little bit funny here. I'm just saying I don't think these should change if I'm returning false. Because sometimes when I give this like this as an assignment, people go change the odometer anyway. And then they say, oh, by the way, you don't have enough charge. So again, I don't expect those to change. So I'm going to put that in my test here that those should not change, right? And then we're going to act. We're going to call, so this will be an actual drive result then is equal to car.drive and anything, right? Driving 1 should not work because there's no charge at all. And then I'll have the actual odometer and the actual current kilowatt hours just to make sure those ones didn't change here. Odometer and current kilowatt hours. Go copy those in. We don't care about the max. Max shouldn't have changed here. And then we'll assert to the equal. So self.assert equal, given the expected drive result and the actual drive result. Self.assert equal, given the actual odometer, expected odometer and the actual odometer, and self.assert equal, the expected current kilowatt hours in battery and the actual current kilowatt hours in battery. Right? So if it's unsuccessful, I should get back false, and my odometer should be 0, and I should have no charge. Right? So let's give that a run. That one worked. And by worked, it was unsuccessful, which seems a little silly, but like we're testing, the code told me, no, you can't do this, right? I got back the false result. So now if it's successful, basically all the same things here. I can copy this now. But if I charge my battery, so let's change the max here to say like 10 and say maybe we can get 5 kilometers per kilowatt hour, right? So now these numbers are important, right? Because these ones matter. So I'm going to say, hey, if I had 10 in the battery, maybe we went 5 kilometers, I should have 9 left. I'm sorry. So if we go 5 kilometers and we get 5 kilometers per kilowatt hour, it should use 1 kilowatt hour here. Excuse me. So to do that, then I have to charge the car. So we're going to call car.charge given 10. we'll charge it 10 because that was my max. So you can use variables if you want here. You could just hard code them in. Maybe variables are better. It's not the end of the world if we just hard code in some numbers. So make a car, charge it up to max, drive 5 kilometers. My expected odometer, or drive 5, right? My expected odometer. I should be able to have gone 5. My odometer should show 5. The current kilowatt hour should have gone down by 1 because 5 kilometers at 5 kilometer per kilowatt hour means 1 kilowatt hour was used, right? And all of a sudden they matched. Uh-oh, it failed. We got true does not equal false. Oh, my expected drive result should have been true, right? Yes, this should have worked. I should have returned to true. I was able to drive that far. This is why copy pasting is rough sometimes. All right, drive successful. So that one passed. Okay. This feels like a lot of work to make sure our code is running. Okay. But this now sets it up with testing here that if I want to go change my car class, that all of these tests don't have to change. And if I were to change something that affects this core functionality and the tests start to fail, I know I screwed something up. Right? This idea that software is expensive to write because you folks are expensive people, or when you graduate, you'll be expensive people, right? This sort of idea, because not everyone knows how to do it. That's sort of the basic economics of it, right? It's a skill that only so many people know, and a lot of people want it. There's a lot of demand for a low supply, that sort of thing. So if a company is going to pay a developer to write some code, the longer they can use that code, the more return on investment they get. Right? That makes sense. If they're going to pay you for 5 weeks of your time to write some code, right? They're sinking in, I don't know, 10 grand or something to write this code. The longer they can use it, the more return they get on their 10 grand investment. Right? So most of the time, the code that we write or the code that's running is old code because it's already been written. Now, if something has to change, they're not going to rewrite it from scratch. They're going to say, hey, I had working code here. Can you just go modify it? Can you go change it a little bit? Can you maintain it, update it here? Hey, something changed in the way that we charge. Go update the charge logic. Sure, we can go and change a small piece here, and then as we change it, all of the tests will still be here to make sure nothing else changed when I added some functionality or I changed some functionality here. So having tests makes sure that as our code evolves, we don't break anything that was supposed to still work, right? So all sorts of ideas in software engineering around how do you make sure that you don't have regression bugs. So I fixed something that was there, right, or that didn't have a bug, and as I changed my code, it regressed, and I have new bugs or an old bug, right? You don't want errors, you don't want bugs in your code. So having tests helps protect against that, right? So it gives you a little more safety as you're working with evolving your code because most of the time that code exists, some poor sap is going to be paid to maintain it, right? Because they want to get their return on investment out of it. We have to go and update it this year for this new feature. We have to go do this, whatever it happens to be, right? So code, most of its life is spent in this maintenance phase, right? The next cool thing, once you have tests, we can automate the running of tests. So not only can I run them manually here, but in my, oops, sorry, what did I do? I don't even remember. So on GitHub, if we go look up, I think it's Microsoft has some here. You can go look at theirs. I think it's VS Code. VS Code. So this is the public Git repository for the VS Code product from Microsoft. They maintain this here, right? There's all sorts of cool things this one does here, right? But one of the things that happens, I think they've got it in here. Yep. So you can look at all of these tests are running here. So anytime code is checked into source control, specifically GitHub here, GitHub is able to automate the process of running the tests and see if they work or not. Right? Did it actually work? Test plan, item validator, main. Right? It ran the test plan. And again, there's all sorts of cool things we can find with details. We can do this. We can set it up later. It's not next class. We'll probably get into that. It's not worth a lot of our time to do right now. But in 2001, we can set it up to actually run and automate some tests so that anytime you change code, all of the tests will run automatically. This is called continuous integration testing. So as we're integrating code, because ideally, like lots of people are working on this project, right? It's not just you. It can work for just you and it can work for a single person, but the workflow's better for teamwork here. As different people are changing the code here, right? They've got 1,900 people who've contributed to VS Code so far, right? Anytime anybody changes the code in the repository, all of the tests are going to run and we're going to see what the results are right away, right? I think we can see, does it give us, yeah. So at this point, the tests failed. Something failed here. These checks were not successful here. So you know, hey, whatever you checked in probably was a bad change. It broke something, right? And then you have to go and fix whatever that happened to be, right? So we get a really cool tool that automates that for us. If you can automate your tests, right? The next step you can take your software to is continuous deployment. Have you ever been to khanacademy.com? Their website is continually deployed throughout the day. So anytime one of their engineers makes a change to the code, it goes through the continuous integration testing. And then if the tests pass, it can push the change out with continuous delivery to their production website. And we don't even know behind the scenes, right? They've automated all this process here. And again, part of this pipeline, the flow of it is we don't know that it's changed behind the scenes, but it increases the speed in which their engineers can deliver changes, which ideally is delivering value. They're kind of a weird example because they're a nonprofit, but that sort of thing. So you've probably heard of Teslas being able to update over the air, right? Teslas can just update themselves because they're connected to the internet. They can push down changes to them. The faster you can push down changes to them, right, the easier that the process happens to be, the faster they can add features. That's one of the cool things they like to advertise, right? You can get the beta versions of all these self-driving features and whatnot. Uh, but of course, it's your fault if you hit someone, though, even if the car was self-driving, because you're supposed to pay attention. That's how they get away from lawsuits, right? I'm pretty sure it'll be forever in beta because that helps present lawsuits, that sort of thing. But if you can get your code, if all the tests pass, you feel good that the change you make works, then you can automatically deploy it to wherever it happens to be. So certain applications are better than others. Web applications are really good at that sort of thing. But any sort of application, you could have this pipeline set up to automatically update itself. I'm going to add new features. Great. It will automatically do that if my tests pass. So all sorts of cool tooling around that. So that's one of the other reasons why tests are so powerful. And again, the only thing we've done is unit tests we're talking about. That we'll stick to the unit test level. There's other levels of tests. You can do integration testing or system testing or end-to-end testing. We're just caring about the individual unit right now. You can get into more of that stuff later. But does the little unit of code, does my one function work? Generally, you do it function by function by function. Does this function do what it's supposed to do? We have tests for it, which is really fun. Uh, so testing is phenomenal because the computer is not going to get tired. The computer is not going to make typos. The computer will check every single time. Does it letter for letter, number for number match? And we don't have to hit run and eyeball ourselves, right? Which is super cool. So now you probably noticed there was a little bit of output here showing because when we load, and we didn't get to modules. It's all right. We can wait for next week for that. When we talk about modules. So all this other code here is going to run. We don't have to worry about that right now. Eric's chair. Okay, cool. So we've got our class. We have tests to make sure that what we think the class was supposed to do, it is doing with charge and drive. Those sorts of things here. Those sorts of things. How's that feel? New concept. So this way we're not writing code here. We're actually writing code that tests our code instead of writing code that prints stuff to the screen, right? And then we can automate it. It's really quick to run. And then so if you run all the tests, right, you can real quick see everything. Oh, not debug. Run all the tests here. See all of them pass, which is a good feeling, right? All of these things are happening and it's really quick. It took a whole, second there. Yeah.
Oh, exercise these tests.
What do you mean?
One more practice.
So when we write classes, we write more tests. So this is not in the Zybooks here. They didn't get into it here, but this is a very practical thing here. So anytime we write it, you can technically test even individual functions. So back when we just did functions, you could test those. Sure. Mainly once we get to classes, we start testing things at the unit level to make sure the classes do what they're supposed to do, right? Because that class is the encapsulation of all the details. And then it's a little bit more interesting, right? Because we have different variables that change, right? When we drive, things happen when we drive, those sorts of things. Yeah, we'll practice more next semester. If you do continue on in 2001, we'll do a whole project with classes and testing our classes and that sort of thing, making sure we do all of that. We're not going to get that deep into it this semester. I just want to intro the topic so you've got it in your head. There's a better way to do things than spit stuff out on the screen, right? That's all.
What is the next class?
2001. So computer science 2 for data scientists. Yep. When is that anyway? Let's see. I think we do, it's still like a split. We do lab in between. Let's see. CIS.
I'm all should I ask you?
200 is the C++ version. So 200 is generally computer science majors or CIS majors take 150 and 200 in C++. Data science majors take 1501 and 2001 in Python because Python's a more useful data science language.
So,
That is discrete structures. So that's like a math class.
since
Uh,
well, these are what will you see this plus about?
you could. I don't think you'll ever take C++. Hang on, let me see. Yes. There's a program map, hopefully you saw, that they should have showed you that says, hey, take these classes this semester, this class this semester. Does that ring any bells? Data science. Here's the, uh, where is it? Not the catalog. Is it the catalog? I don't think it's the catalog. Hang on. It's in here somewhere. Curriculum requirement sheet and sample course. It's weird they hide this thing down here. It's like, this is the most interesting page here. Of course, they moved it again. Hang on. Data science. So your sample pathway. Here we go. This is the interesting file. It says, hey, semester one, take these classes. Semester two, take these classes. Semester three, on and on and on. Right? So 2001, more calculus. Your third semester, right? Your sophomore year, you'll take Calc 3 and discrete structures and Intro to Data Science, which is a stats class, and linear algebra. Like this is entirely math. Your fall sophomore year, all math. It's a rough semester if math is not your thing, but hopefully you're in math because you're into data science. So the intro to data science class, the stats class, I believe teaches R, the R programming language, which is super cool. Linear algebra is just math. So depending on who's teaching discrete, I don't actually know who's teaching it right now. The person who used to teach it, it was just a math class. You're supposed to do some software projects, but they weren't doing them because reasons. And I don't get to tell people what to do. It's not my job. So might have changed with the new person teaching it. I'm not sure, but it's mostly a math class. So that's fun. Calculus obviously is a math class.
Do you also teach as 2001?
Yeah, yes. Typically it's me, unless they get rid of me. I've been doing 1501 to 2001 since we started the program. Right. And then data structures you'll take. This is another CIS. This one's a lot of fun. Um, People take this from all the CIS majors, so it's language agnostic. So you'll get people who've transferred in who only really have Java. You'll get people like you who've only taken Python. You'll get the traditional CIS folks who've only taken C++. So the idea is they'll show you algorithms and you implement it with the language of your choice. The book that we use for 2001 used to be the book. I think it still is the book that they use for this, or at least they start with for this class. I think it goes beyond the book. Typically when they teach this one. I talked to them a couple of years ago about the class. The guy who usually teaches it. Um, More stats, lots of fun. So IMSE, I think, is the typical one, probability of statistics or calculus-based statistics. It's kind of interesting. Sure. And then ethics. Thankfully, we teach ethics like as a completely separate class. This is phenomenal because it's hugely important, especially in data science, as we start looking at ethics around what we're doing, how we're doing it, why we're doing it, those sorts of things. Um,
Is
Data
there,
science. Sorry.
is there anything different from C++ and Python in terms of ability?
In terms of what?
Ability?
So you can do more with C++ because it's a lower level language. A lot of like embedded systems work you can do in C++. You don't do that with Python. Right? Python's a higher level language. It runs on computers mostly or servers places. But it's more widely used. You get more libraries for data science sorts of things in Python. So it's the more common language applicability wise. But you can do tons of things with C++. It's a fun language, but it's a little more awkward to learn. It's not my favorite.
Which one?
It's Python for sure. Oh, Python's fantastic. So much easier. Like it just makes much more sense. Yeah. So data science one is fun. It's an ECE course. So we have our friends over the ECE department teach it, and then we teach data science two here back in CIS. Um, you'll take software engineering one. Super happy because software engineering is amazing. That's my passion. Um, And then your senior design sequence, your senior year is really fun. You do a year-long project or 2 semester-long project, essentially in a multidisciplinary group, which is really cool. And you can show it off. And this is like as you're applying for jobs, you can talk about the school project you did. More stats, of course. And then your application area, your focus areas here as you start getting those credits in. So hopefully they showed you this map. Advising did, maybe? Is someone you're saying no? Okay, someone said yes. That's good. Made me happy. Um, so yeah, lots of fun stuff as you go through it. So oh yeah, our class. So 2001. Yeah, we're meeting Tuesday for. Oh, we have lab first. That's fun. 12 to 1:45, and then lecture Tuesday, Thursday, 2 to 3:15. So we'll be shifting Tuesday, Thursday instead of Monday, Wednesday. Um, so I think that this lab format will actually work better. So we can have 2 lectures and then the lab, and then start new stuff. Do 2 lectures and then the lab. So it's not split in between the 2 lectures in the week. Uh, I like to organize stuff by week. It just, I don't know, makes more sense to me. So next semester, that's the plan. We'll see how well that goes.
What's all that for?
The lab Tuesday 2 to 1:45 or 12 to 1:45, and then the lectures 2 to 3:15. We're gonna be over in the Castle building. We got a hike. That's fun, all the way across campus.
And
Yeah.
then we went from Thursday.
I'm sorry.
Then we left on Thursday.
Yeah. So lecture Tuesday and Thursday. For this is the winter, yeah, the 2001 class. So they changed it up a little bit. This actually, I have a Thursday night class I'm going to teach. So I said, can I not come 3 days a week? My department chair was like, sure, we'll move it to Tuesday, Thursday. And it worked out nice. So saved me some driving. All right. Yeah, so we're doing pretty good. We did tests, looked at classes. I think that covered all the stuff in the Zybooks that we had here. Let's see. Yeah. Don't worry too much about the interface bit. The customization, overloading, we'll get more into next semester as well. Like it's here. Don't worry about it. We'll do this overloading bit next time. So just breeze through it. You don't need to go too deep. And I don't think any of these make you use any of that stuff either for the lab. So we should be in pretty good shape there. All right, let's talk about the project. Next project, super excited. I think I wrote this one out already. Yeah, I didn't publish it yet. Look at that. I'm like ready here. Okay, so nothing super crazy for this one here, just some practice. So we're going to write a class for item that has attributes for quantity, name, and unit price, right? We'll have set and get methods for quantity and unit price, but just a get method for name. So like once you make an item, the name can't change, right? Once you're selling fruitcake, it's always fruitcake. If you want to change the price of fruitcake, go ahead, change the price of the fruitcake. If you want to change the quantity because you've realized 12 fruitcakes was too many fruitcakes, let's change the quantity back, to a reasonable number like 6 fruitcakes. It's probably a little better, right? And then we're going to add a function get total price, which does not have a total price attribute. We're actually calculating the quantity times the unit price. So it looks like a get function, but it's actually doing some arithmetic behind the scenes. Yeah.
So I will have at least 5 functions. So I have a set for price, a set for
Quantity.
quantity,
Yep.
and get quantity and then right.
Yep. And a get for name. Yep. And then we'll also have a get total price, but there's no total price attribute. We're going to compute this one because the reason is if you wanted to store total price as a class level attribute, you could, but then when quantity changes or unit price changes, we'd also have to change total price. So like there are trade-offs, and when you talk about algorithms analysis and design, then you can look at the trade-offs of is it faster to store something because it takes more memory, or is it faster to compute it? Those sorts of things. For now, we're just going to compute it. We're not going to store it. We're just going to compute that thing here. We're also going to add a string method that returns a string value of all the details, like 7 bananas at 30 cents each, and then the total price is 210. I think we looked at doing this string method, right? Do we do that in our class? Do we do a string? We did that for Connect 4, right? I think we did that Connect 4. Yeah, because that was the last bit we had to do so we would not be tied to printing. We said, hey, to represent myself as a string, I'm going to return a string here. Okay. The reason we do that, let me go back to classes here. We didn't do that before. If you just try and print a class out, like if I were to print Eric's chair, I don't get all the details of Eric's chair. Just saying print Eric's chair gives me garbage. I get main chair object at bleh. I get here's the memory location where this thing is stored. It's a type of chair. It's an instance. It's an object here of chair. So if you don't have the string representation, you can't print yourself out, right? If you want to add a string here in chair, right? Let's just go do that here. Just a silly one here. Define string, return, I'm a chair. Again, not a good one here, right? But now when I run here, I get I'm a chair because that's the string that we gave back out, right? When you asked for a string, when you print something, it asks for it as a string. So that sort of thing. So we'll have that for our item that returns the quantity, the name, the unit price, and then the total price, right? All those things together, jam together as a string. Okay. So that's the item class. Then we have a shopping cart class that has an attribute for a list of items. So the shopping cart is really just a list of items we've put in our proverbial shopping cart. We're kind of imagining here, right? We're trying to model this is what we're going to do in real life. So we're going to have a public function for add item that accepts an item and adds it to our list. So it's not going to accept the item name, the quantity, and the unit price and make an item. It says, if you give me an item, I will put it in the cart, right? So list is just a list of items. We're going to have a function for receipt, which returns a string value of the receipt with each item with details and total price, and then a grand total of all the items. So I should be able to get a receipt from my shopping cart. Right? Imagine we're one of those newfangled Amazon stores that just monitors all the things you put in your cart, and you can just walk right out and it'll charge you automatically on the way out, which is super cool. I'm excited for that sort of thing, and I'm sure nothing can go wrong with that technology. Obviously, it'll be perfect. Yeah, definitely. Um, sure. And then we're going to write unit tests for item and shopping cart. Okay. Basic tests, nothing super crazy here. We don't have a lot of interesting logic happening. So when you add something to the shopping cart, it should come out in the receipt, right? That's really we're so we don't really need to test add item separately. We're just testing once I add an item, does it show up on the receipt? We don't even need a get items, anything like that. We're just gonna have the receipt. So once you put it in your cart, you can't change your mind. That's okay. We just don't worry about all the other details here. I just want a kind of a basic example. We're going to go deep on this next semester, but I want people who have written classes and have written tests for their classes here. Okay. And then once we have the unit test, then we're going to write a program that lets you add items to your shopping cart or print the receipt, and you just loop until you're done. Hey, welcome to Meyer. What do you want to put in your cart? Get the details, add it to the cart. Tell me when you're all done, and I'll print out the receipt for you. Okay. So three different pieces here, or four different pieces, right? The item class, the shopping cart class, the tests for both, and then the program. Oh, I got to change. This is not 10 points here. This one is 20 points. I got to keep upping the points because you don't get to forget anything here. Let's do 20 points, and I'll add a rubric here. So this will be for project 3. Okay. And then we'll use this one for grading. So this is the item class. It's 5 points. My shopping cart class, 5 points. Unit tests for item and shopping cart, 5 points. And then program that lets you shop and print receipt. I think that's about right. 5 points there. So that's 20 points, right? 5 points for the class, 5 points for this class, 5 points for testing it, 5 points for making the program that actually lets you go and do these things. Okay? So again, next week is a little bit lighter. We don't have too much to do with exceptions and modules. Exceptions is a great topic. We'll spend a good amount of time on exceptions, but it's relatively straightforward. Modules is super fast. This idea of having separate files, these are modules. Modules are just files. We'll get more into those details and why I had to say this like import thing here, what this actually was, and that'll make more sense next week, okay? That's unreasonable. So we've got some time. We'll work on this. When we do lab next week, that'll be on exceptions, right? Because the way our labs are a little bit split here. We got this project, we got 2 weeks for this one, okay? And then that puts us at the 15th. Where did that go here on our schedule? Let's see. So I think the 15th, then, yeah, we finished up files, and then we can talk about the final project on the 15th. And that gives us almost a month for the final project then. Again, ideally, if you get it done early, great. You know, you can spend your time how you want. We'll go from there. So I want to make sure we get to the final project before Thanksgiving break in case you want to spend your time on it. So should be pretty good. Okay. Thoughts, concerns? I know classes, it's big. It's a very different way of writing code. So you'll get there with it. Okay. It's okay if it's not 100% right now. So it's a very different way for us to write code and approach it. It's mainly for people. right, for developers because it's a great way for us to think about these sort of topics. You don't have to use them. Right? We did like this ugly dictionary of dictionaries for the lab, and that worked, but that's a lot harder. It might not feel a lot harder yet, but I promise you, it's a lot harder than using classes. Okay,
You think classes are simpler?
maybe not even simpler, but I feel like intuitive might be the right word. Like we understand nouns and attributes and verbs. So if we think about how do I model some real behavior in my program, which is generally what we're doing, we're taking a real world problem and solving it with code, right? How do I model that real world thing, right? Like how do I make a lottery ticket? A lottery ticket has a bunch of numbers, right? What do we do with lottery tickets? Well, you see if it wins or not. So to compare to do my lotto ticket win or not, I have to give it the winning numbers or a winning ticket, and it can compare itself and tell me did it win $2 or $4 or whatever here or nothing, right? Because most of the time you win nothing. So the lotto's a big scam, uh, that sort of thing. So we can take real world topics and sort of encapsulate them with code in a way that feels like it makes sense. That sort of thing. So, or I can make a class for a computer, right? It has all sorts of attributes, like how much memory it has, its CPU, all the details about it, and everyone has their own instance of computer, right, with their own set of attributes and things we do with it, like run a program. We could run a program, and any sorts of verbs that we can open it, we can close it. Those sort of we can model real behavior more easily with classes. Is sort of the real value there. All right, awesome.
Actually, this don't make sense to but it makes sense.
It's not until you use them more. So you have to see how they're used more before it becomes a little more comfortable to use the classes for sure. Yeah, it'll take a little time.